Now the Thevenin equivalent circuit. Okay. Now as I told Thevenin circuit, how can we calculate Thevenin equivalent circuit? Calculate the one is VT, right? That would be equal to V. And another thing calculate, that is RT. For RT, actually in table there is a dependent. We'll have one formula, that is V, open circuit voltage divided by the short circuit current. Okay, this is the open circuit voltage, and if we connect a plain wire across the load terminal and we need to calculate the current across it, that would be a short circuit current. Okay, so from these point, like suppose A and B, from this point VOC will be calculated, and from these points only ISC will be calculated. So RT with VOC divided by ISC. Clear? Okay. Now the question arises that how can we calculate VOC, right? How can we calculate ISC, and how can we calculate RT? In order to determine this VOC, ISC and RT, VOC calculate voltage across the terminal where load resistance was connected A and B. Short circuit, draw a plain wire, a plain line or wire between. Then we need to calculate the current. Okay. RT, turn off all the sources. I told you, turn off all the sources. Voltage source must be replaced by short circuit, right? And current source, this it must be by the one circuit. Like they have taken one simple example. This they have used voltage division. Do you know what is voltage division rule? So for one condition that's in series, right? Like this is the original, and they said we need to calculate the Thevenin equivalent circuit, correct? So for this we calculate first, then we need to calculate RT, correct? So VT, how we equal to VOC, right? So for this it V. So voltage across OC, can we say that that would be the same voltage across R2, because it's in parallel, and in parallel voltage would be the same, right? So for what we can write down, V equal to R2, correct? So for this to apply the voltage division rule. Clear? So what does voltage division rule says? That formula, that is the total voltage. You know the formula na? Like suppose this is 1, 3, 10 or 5. Now tell me, want to calculate the voltage across 5 ohm by using voltage division rule formula. That 25 over divided by the resistance. So we'll do the same thing here. That would total voltage is 50. Yeah, that depends on the circuit totally. In this case, 150, they both are connected in series. That's why you will be able to apply voltage division. If suppose one more, if suppose there is a parallel across this, then you need to calculate the current across that, right? And for current, you need to use mesh analysis or you can use nodal analysis. So after solving, we'll get it as 5 volt. So one value we got it, that is correct. Now another thing, calculate RT, right? For RT, what we need? We need to calculate ISC according to the formula. As I told you, the formula of RT is divided by IS. So for ISC, short circuit. Now we need to calculate the current. Now it's totally up to it, not a forcefully, that it's totally up to you. If you want this is for calculation of ISC or you want to use mesh analysis for calculation of ISC, that is totally up. Whatever you want to use, then okay. So now tell me, method will you want me to follow, nodal analysis or mesh analysis? They have done directly actually. VS by R1, yeah, because this, tell me which okay, they have followed the that current will always follow least resistance path. Suppose, suppose you are moving like this. You are moving from a battery. You need to move towards the battery only. Now you have two options, that will you have having a plain path or you are having a path where lots and lots of senses. So which path you will, you are suppose driving a car, you will go through the other way where a plain path, although it's a long path, right? So you will not go through this path. If you are going through this path, then I would be equal to how much? By R. Let's suppose this 10, this is 100, this is 20. So simply if we want to calculate ISC, R would be 10 only because current is not 20 ohm. So in this case we consider 20 ohm. So how much the current? 10 ampere. Understood? Now in this case tell me, like we calculate ISC, get ISC, because current will not follow through this path, equal to V over 1. So it would be 15 by 100. That would be 0.5. Now we substitute the value and get the value for RT, right? Well, want to calculate V Thevenin voltage, we calculate RT Thevenin resistance. Both are combined with other. Our final Thevenin circuit. Got it now? Yeah, 1 volt. Let's take the new example. Tell me about how can now you'll have an idea. Calculate. They have, right? Why it is, calculate I3, I1, I3, right? I1 is I3, I told current current source, correct? Or again, element, understood? Ultimate, let us I2, I1, I1 first, I1, I1 is 10 to IX, IX, I1. Now you'll, what would be, IS. They have again the current with, right? Correct? IX is ISC, IS. Plus starting from path where current source isn't. I told you current source, obviously currents. And you don't need to IX, you have, can you solve variable and of IX, IS able to get the value for get RT equivalent circuit. How can we get the Norton? Again, full Norton. They said a two terminal circuit can be like, remember in theory we, right, calculate RT and both connected, but you don't need to calculate calculate current. Okay, why not? They said that would be IN. Calculate RT, calculate RN. That would be RT only. RT and RN both are differences that here they have connected in and here parallel. Procedure, there is no, like the same way you did calculate RT, same way calculate RN. That's why they didn't use RT only. Okay? But the difference is that here the RT was, but in the RT is parallel. Got it? Take any and Thevenin equivalent Norton. We need to calculate this. IN is how by RT. Got it? Let's try solve NV. Again, what is it? IN, calculate and RT. That's what exactly thing done for, right? How can we calculate V? the views, right? Suppose this is I1, I2, I1 plus I2 plus I equal to, tell me what is I1? I2 is round, I3 by dependent x. And do you x is according to I into R. I is I3, R is I3, right? 20, one of them, and calculate IS, right? How can you IS by calculate IS by, again it's again current will IS like per move. Always start with the first start, have to start and start because, right? IS I1, I1 plus 50. Can you go to path where current source? Path where current source is present. Can't go through. Get the direct equation. I1 and by 4. Direction of I1 is here. What is according to I into R, but there is no current flow. I1 is now only RT. Out in, right? Kinds of judge when parallel. Actually, like that judge that these are in parallel. Whenever working in parallel, another method. What would be the another? Calculate RT have I. Test means tests. Apply a test current or apply a test current source. Like here, I like this. I that is test page. Got it? And if you apply current source, like current as like, and that current, got it? So that would apply test currents, then calculate. Here, prices, calculate I test. First, we need to apply test voltage. External or itself. If we want to calculate, better to use L analysis. Calculate current mesh analysis. Here, here we want to calculate voltage, right? And if I currents, that would be 1 ampere. But we do 1 ampere. Can't take testing purpose. We either not guided by I test. Test is I test 1 ampere 5 divided by 5 RT. How can we RT? RT as I current test 1 here. Now RT 5. Last question, write the current source. Correct? Now it's not like that we apply current source. There it's your wish. Here they have applied the voltage they told by all the method. Clear? test by I test. How much is for voltage test source? I'm asking how much is test source? That is 1 volt. Set the value for current. Then we'll test some amount of current is right, and that current by I. Now we need to calculate I test. I1, I2 and I3. I test like I3 and I test, they are in the same direction or direction. I test would tell me the how many total equation calculation I3. Get the value I3. First tell Ix I, right? I I3 RT. The currents, or we can vice versa, currents voltage. Got it? There is one condition, and current parallel, right?